All right. Welcome back, everyone, to another deep dive.
Yeah.
This time we're tackling a topic that's absolutely crucial for any retaining wall project. I mean, it can make or break the whole thing.
Yeah.
We're talking drainage, internal drainage systems for those segmental retaining walls, or SRWs, as the engineers like to call them.
Right.
So if you're planning on building a retaining wall, or maybe you've already got one, and you want to make sure it stays put for years to come, you're in the right place.
Yeah, you need to get the drainage right.
You really do.
It's that important.
Now, we've done our homework, right? We've got a stack of engineering manuals and best practice guides, even some real-world case studies, all to help us break down this sometimes, well, kind of complicated topic.
Yeah.
But we like to keep things interesting here,
Yeah,
so
absolutely.
no dry lectures, we promise.
It's all about practical advice and making sure you guys have the knowledge to create a retaining wall that will really stand the test of time.
That's right. So let's kick things off by talking about the arch nemesis of any retaining wall. I mean, why is water so dangerous for these structures?
Well, retaining walls, they look pretty simple from the outside, right? But what a lot of people don't realize is there's a whole lot going on beneath the surface.
Right.
I mean, water and the way it interacts with the soil behind the wall is a huge factor in how well that wall is going to perform over time.
It's all about physics, really, isn't it?
It is.
That pressure
Yeah.
that water exerts.
In hydrostatic pressure.
There it is, the fancy term.
Yeah, that's the one.
So can you break that down for us a little bit?
Yeah, so basically water is heavy.
Yeah.
And when it builds up behind a wall, it starts pushing against it with a surprising amount of force.
And that force, that hydrostatic pressure, it can lead to all sorts of problems, like what?
Oh, I mean, you can get bulging walls, cracking, even total collapse in extreme cases.
Yeah, that's a nightmare scenario.
It is. Nobody wants to see their hard work crumble like that.
And it's not just about the water itself, is it? The type of soil behind the wall also plays a big part.
Oh, absolutely.
We were looking at some of these sources earlier, and I remember there being a lot of talk about fines and how they can impact drainage.
Yeah, the fines are a real problem. So basically, you want the water to be able to flow through the soil easily, right? And that's what we call permeability. You want a permeable soil.
Got it.
So the best kind of material for that is like a granular material, something like gravel or sand. Those bigger particles, they have space between them for the water to move through.
They let that water escape.
Exactly. But when you have fines in the mix, those tiny little particles of silt and clay, they fill in those gaps, and the water just can't drain away as easily.
It's like clogging up a drain.
Yeah, exactly. That's a perfect analogy.
Now, we actually saw a pretty startling statistic in one of the engineering manuals.
Oh, yeah, table 5, right?
Yeah. It showed how even just a small percentage of fines can drastically reduce the permeability of the soil.
It's crazy how much of an impact those tiny particles can have.
Right. So choosing the right backfill material is super important, especially if you know you're dealing with a soil that has a lot of those pesky fines.
Definitely. Especially if your soil has a lot of fines, you really need to pay attention to your drainage system. You can't skimp on it.
Okay, so we've established that water is the enemy, and fines are these little accomplices making things even worse. So how do we combat this threat?
Well, that's where the hero of our story comes in, a well-designed drainage system.
The drainage A-team.
Yeah, you could say that.
So what are the key players on this team? What makes up a good internal drainage system?
Well, first up, you've got the drainage stone. This is like your first line of defense. You place it directly behind the wall blocks.
Okay.
And it's usually a layer of gravel or crushed stone. And its job is to prevent water from building up right against those wall units.
It's like a buffer zone.
Exactly, keeping the water at bay.
Now, as the water percolates down through the backfill, where does it go?
Well, we need a way to collect it and channel it away, right?
Yeah.
And that's where the heel drain comes in.
The heel drain.
Yeah. So it's basically a trench. It runs along the back of the wall at the bottom of the reinforced zone.
Okay.
And it intercepts all that water flowing down and directs it towards the outlet.
So it's like a highway for the water to escape.
Yeah, that's a good way to put it.
And then what? Where does that water go after it hits the highway?
Well, it needs an exit ramp, right?
Right.
And that's where the toe drain comes in.
The toe drain.
Yeah. This carries the collected water away from the base of the wall, so we're preventing saturation of the soil at the bottom and any potential instability.
Okay, so heel drain collects the water and toe drain carries it away. It's a tag team.
It is a well-coordinated team effort.
Now, what if we're dealing with a site that has a high water table, meaning there's groundwater present?
Yeah. That adds another layer of complexity.
Right. So do we need some special kind of drain for that?
We do. That's where the blanket drain comes in. It's like a safety net that sits underneath the entire reinforced zone of the wall.
Oh, wow.
And it intercepts that groundwater before it can seep up into the backfill and cause problems.
So it's an extra layer of protection for those tricky situations.
Exactly. It's essential in those cases.
Now, are there any other drainage specialists on this team?
There is one more. Sometimes you might find you've got these localized areas where water tends to collect.
Right.
For those situations, you can add what's called a chimney drain.
A chimney drain.
Mm-hmm. It's basically a vertical column of drainage material, and it helps to channel that water away from those specific spots.
So it's like a targeted strike force dealing with those stubborn pockets of water.
Exactly. It's a more focused approach to drainage. Now, we've been talking a lot about gravel and drainage stone, but there's one more crucial component I want to mention, and that's the geotextile filter fabric.
Yes. The mysterious fabric we see wrapped around drainage pipes and stuff. What's the deal with that? What does it actually do?
It's super important. Think of it like a barrier that stops soil particles from migrating into the drainage layers. Because over time, those drainage layers could get clogged up with soil, and that would make the whole system useless, right?
Right.
So the geotextile fabric, it acts like a filter, kind of like a coffee filter, keeps the grounds out of your cup.
I like that.
So yeah, it might seem like a small detail, but it makes a huge difference in the long-term effectiveness of your drainage system.
So we've got our Drainage A team all set, each member playing a specific part in keeping that water away from the wall.
Mm-hmm.
Now, earlier you mentioned how important it is to choose the right backfill material.
Absolutely.
We talked about gravel and sand being ideal because they're so permeable.
Mm.
But are there ever times when other materials might be considered?
Yeah, so granular materials are definitely preferred, gravel, sand, that kind of thing. But there are situations where you might use cohesive soils, which basically means soils with more clay in them.
Okay, but didn't we say earlier that clay can be bad for drainage because of those fines?
Yeah, you have to be really careful with clay because of those fines.
So when would you actually use cohesive soils then?
Well, sometimes it comes down to practicality. If cohesive soils are readily available on site, it might be tempting to use them, but you have to be very careful. There are some specific criteria that need to be met, and it's best to have an engineer involved in that decision.
So it's not as simple as just digging up some soil from the backyard and calling it a day?
No, definitely not. I mean, using cohesive soils in a retaining wall drainage system requires a deeper understanding of soil mechanics.
Right.
You need to know things like the soil's plasticity index and its liquid limit.
Okay, now those sound like some pretty technical terms.
Yeah, they are a little bit technical, but basically the plasticity index tells you how much you can mold the soil without it cracking, and the liquid limit tells you how much moisture it can hold before it basically turns into mud.
Oh, I see. So those properties, they're important for understanding how the soil's going to behave under different conditions.
Yeah, exactly.
So if you're thinking about using cohesive soils for your drainage system, please talk to a qualified engineer first.
Oh, absolutely. Don't just wing it.
We don't want any DIY disasters out there.
Nope. Safety first.
Okay, so we've talked about the right backfill material, the different drainage components, and how they work together to move that water away. What other key things do we need to think about when designing our drainage system?
Well, one of the most important things to remember is that there's no one-size-fits-all solution.
Okay.
Every site is different, right?
Right.
So you've got to think about the specific conditions on your site. What's the soil like? Where's the water table? What kind of loads is the wall going to be supporting? All of that factors into the design.
We need to do our homework and really understand the challenges our wall is going to be facing.
Exactly. And remember, it's not enough to just collect the water, right? We got to make sure it has somewhere to go.
We got to give it an escape route.
Yeah, exactly. We need to design for adequate outlet capacity.
So where does that water actually end up?
Well, ideally, you want to direct it to a safe location where it won't cause any more problems. So that could be a storm drain, a drainage ditch, or even just a lower area of your property that can handle the extra water.
It's like planning the water's vacation.
Yeah.
We got to send it somewhere nice where it can relax and not cause trouble.
Yeah. That's a good way to think about it.
Now, how do we know if our drainage system can actually handle all the water it needs to?
That's a great question. And that's where the concept of a flow rate factor of safety comes in.
A flow rate factor of safety.
Yeah. It's basically a built-in buffer to make sure your drainage system can handle even those really heavy rainstorms.
Okay, so it's like having a backup generator for your drainage system,
Yeah.
just in case things get really intense.
Exactly. You got to be prepared for the worst case scenario. So a well-designed drainage system with a good flow rate factor of safety will give you peace of mind, knowing that your wall can handle whatever Mother Nature throws at it.
All right, we're starting to get the big picture here. But even with the best planning and design, things can still go wrong, right?
Yeah, unfortunately, that's true.
I mean, I've heard some horror stories about retaining wall failures.
Yeah, and that's why we're going to take a look at some real-world case studies.
Ooh.
Yeah, so we can see what happens when drainage systems fail to do their job.
It's like a cautionary tale.
It is. It's a reminder of why we need to get this right from the start.
Okay, I'm ready for some drama. Hit me with those case studies.
All right, well, one case that really stands out is a retaining wall that started showing signs of distress within a few years of being built.
Uh-oh.
Yeah, it started with some minor bulging and cracking, but eventually a section of the wall completely collapsed.
Wow, that's pretty dramatic. What went wrong?
Well, when they investigated, they found that the drainage system was totally inadequate. The backfill material was poorly compacted, and it had a lot of those fines in it, so the water couldn't drain away properly.
It was like a recipe for disaster.
It was. The water built up behind the wall, saturated the soil, and eventually it just couldn't hold the weight anymore.
So it was a classic case of poor drainage leading to a very expensive headache.
Oh, absolutely. It's a stark reminder that we can't cut corners when it comes to drainage.
All right. Point taken. Don't skimp on drainage. What about another example?
Yeah, well, there was another case where the retaining wall actually had a drainage system, but the outlet was improperly designed.
What happened there?
So during a big rainstorm, the drainage system collected the water like it was supposed to, but it couldn't discharge it fast enough. The outlet pipe was too small and it got overwhelmed, so the water backed up behind the wall and caused all sorts of problems.
So it's not enough to just have a drainage system. It has to be designed properly for the amount of water you're expecting.
Exactly. You have to consider the site conditions, the rainfall patterns, the whole 9 yards.
Okay, these case studies are pretty sobering. But before we scare everyone off from building retaining walls altogether, let's shift gears and talk about how to avoid these pitfalls. How can we make sure our drainage system is up to the task?
Well, one of the best ways to ensure success is to bring in the experts. Consulting with a qualified engineer, especially during the design phase, can make a world of difference.
It's like having a coach in your corner, guiding you through the whole process.
Exactly. A good engineer can assess your site conditions, analyze those soil properties we talked about, and recommend the best drainage system design for your specific project. They can also help you pick the right materials and make sure everything's constructed according to those all-important industry standards.
Okay, listeners, if you're serious about building a retaining wall that will stand the test of time, consulting an engineer is a wise investment. It's like buying insurance for your project.
Absolutely. It's peace of mind. Now, speaking of materials, I want to talk a bit more about those different types of drainage products that are available.
Ooh, yeah, let's get into the nitty-gritty. We mentioned gravel and drainage stone earlier, but I know there are other options out there, like those geocomposite drains, right?
Yeah, geocomposite drains. They've become really popular in recent years, and they offer some real advantages over traditional gravel drains.
Like what? Fill us in.
Well, for one thing, they're much thinner than gravel drains, which can be a real space saver in tight areas. And they're also much lighter and easier to handle, which makes installation quicker and more efficient.
So less backbreaking work.
Exactly. And of course, they're engineered to have a really high water flow rate, so they can move that water away from the wall quickly and efficiently.
They sound pretty high-tech.
They are. They're kind of like the next generation of drainage technology. They are a bit more expensive than traditional materials, but their performance and ease of installation often makes them worth the investment.
Okay, so if you're looking for a top-of-the-line drainage solution, geocomposites might be the way to go. But with all these different drainage components and materials, how do we know which ones are right for our particular project?
Well, that's where the expertise of a qualified engineer comes in handy again.
It's like going to the doctor. They diagnose the problem, and then they prescribe the right treatment.
Exactly. They can look at your site, figure out the water challenges you're likely to face, and then recommend the most appropriate drainage system design and materials. And just like with a medical diagnosis, early detection and intervention are key. If you can address those potential drainage issues during the design phase, you can save yourself a lot of headaches and costly repairs down the road.
Absolutely. It's always better to prevent a problem than to try and fix it later. Now, before we wrap things up, I want to touch on one more crucial aspect, and that's maintenance.
Oh yes, maintenance. That's a really important point. We can't just build a great drainage system and then forget about it. We need to make sure it continues to function properly over time.
So what does a good retaining wall drainage system checkup involve? What do we need to do?
Well, the first thing you want to do is make sure those drainage outlets are clear. Make sure there's no debris blocking them because leaves, twigs, all sorts of stuff can clog them up, and that'll make your whole drainage system useless.
It sounds like a simple task, but it's easy to forget about, right?
It is. But it's so important for keeping that water flowing away from the wall.
It's like cleaning the gutters on your house. A little preventative maintenance goes a long way.
Exactly. Now, besides checking those outlets, you'll also want to periodically inspect the backfill material behind the wall.
Okay.
Look for any signs of settlement, erosion, or any changes in the soil texture. You're basically playing detective, looking for any clues that something might be amiss.
So we're looking for any changes from the baseline, right? Anything that looks different from when we first built the wall.
Exactly. And if you do notice anything unusual, it could be a sign of a drainage problem that needs further investigation.
Got it. Early detection is key.
Absolutely. Now, one more thing to add to your retaining wall maintenance checklist is to check the gutters and downspouts on your house or any nearby structures. Make sure they're directing water away from the retaining wall, not towards it. We don't want to accidentally create a waterfall that's dumping water right onto our beautifully engineered drainage system.
Right. We don't want to sabotage our own hard work.
Exactly. So a little bit of attention and care can go a long way in keeping your retaining wall healthy and stable for years to come.
All right, we've covered a lot of ground today. We talked about why drainage is so important, all the different types of drainage systems and materials, and even touched on maintenance. But before we wrap things up, I want to leave you with a few key takeaways that will help you create a retaining wall that truly stands the test of time.
Yeah, good idea. Let's recap those essential points.
All right, so first and foremost, remember that drainage is not just some optional add-on.
Right.
It is a fundamental part of retaining wall design and construction. You can't skimp on this.
Yeah, it really is the foundation for a successful project. Invest the time up front to understand your site, choose the right materials, and create a drainage system that can handle the water.
And don't be afraid to call in those professionals. Consulting with a qualified engineer can save you from a lot of potential heartache down the line. It's like having an insurance policy for your retaining wall.
Absolutely. They can help you navigate all the complexities of soil mechanics and make sure your design is sound.
And speaking of insurance, remember those maintenance tips we talked about?
Oh, yeah.
Regular checkups and a little bit of preventative care can go a long way in keeping your drainage system functioning properly.
It's easy to forget those little tasks, but they can make a huge difference in the long run.
They really can. We don't want your retaining wall to become a case study in what not to do.
No, we definitely don't. Okay, so far we've focused on internal drainage systems, which are essential for managing the water behind the wall. But what about the water that actually escapes the drainage system? Where does it go from there?
Yeah, that's a great point. It's something we need to think about, right? We've been so focused on getting the water away from the wall that we haven't really considered what happens to it next. So we need to think about the bigger picture of water management on our property, not just the area around the retaining wall itself.
Exactly. Think about the natural drainage patterns on your site and how the water from your retaining wall drainage system might affect those patterns.
That's some good homework for our listeners.
It is.
Explore those broader water management considerations. Make sure your retaining wall project is not only structurally sound, but also environmentally responsible.
You got it. We can have a beautiful retaining wall and be good stewards of the environment at the same time.
Absolutely. That's it for today's deep dive into retaining wall drainage systems. We hope you found it informative and maybe even a little bit entertaining.
Yeah, we had fun. Remember, knowledge is power. And when it comes to retaining walls, proper drainage is your superpower.
Until next time, happy building.
See us.